Hi everyone. Okay, welcome back again. Thanks for returning. Hi again. Hi again. Hello if you're new. Um, so the last video seemed to go okay. It was good fun. Now I've just spent a little while recording a new video just to find I didn't have the microphone plugged in. Things will go horribly wrong. So, okay. Well, at least I know what it is that I did and I can run through this quicker because the telescope is a lot more set up than it was. So the telescope is polar aligned. It, as you remember, talking about in the previous video about Polaris being very close to the north celestial pole, so that when the Earth is rotating and Polaris seems to be the star that doesn't seem to hardly move in those long exposure photographs. Well, the telescope has been set up so that when it's rotating and moving at the same speed as the Earth, it's also in the right position too. I've already done some plate solving. Now, plate solving is essentially what I call "Are we there yet?" navigation. So imagine you're driving along in your car and you're heading for Ipswich, and your navigator's got the map and you're looking out the window going, okay, is this Ipswich? And then the navigator's looking at the map saying, well, I don't think so, we're not quite there yet. And then somebody's, are we there yet? No. Okay, drive a bit more, look out the window, is this Ipswich? Looking at the map. And essentially that's what the software does in Nina, is that when we tell it to go somewhere, and this is just one methodology for doing this, but this is what Nina uses, is that we tell it to basically take an image of the night sky, compare that to an internal star map. Well, the stars are this way and I've got them this way, so something's wrong. You're pointing in the wrong direction, telescope. So what it does, it then tries to move the telescope into the right position, takes another image until eventually, yes, I'm happy. Now, quite often those images, those star maps are quite limited, that's inside the computer here. So what ends up happening is that it takes those photographs and sends it off online to a website called astrometry.net, which is equivalent of asking a local. So we've got our map in the car, we're driving along, are we at Ipswich? Are we there yet? No, the map says not, it's I don't know where we are, we're completely lost. So then you stop and ask a local, who then says, you need to go left, right, left, right, left, right, and then you're there. So that's what I've been doing this evening in the video where the microphone wasn't working. So I've slew to Polaris, and if I do an image now of Polaris, and let's do 5 seconds, it should be pointing at it if everything has gone right. If not, we might have to plate solve. So let's look at the image. There we go. So there's Polaris. Here is our north pole star, and our star that's quite close to the rotational point of the Earth. If there was like a line drawn straight up from the north celestial pole. So what we can do is we can do a plate solve like so, and what happens is it starts taking I've set it to 3 seconds, so it takes a 3 seconds exposure, and now it's looking at that image and comparing it to the map, and right, it's slightly off. So here we go, it's doing this analysis to say, okay, compared to the stars that are in our map, how does this image compare? So it'll either fail or it'll pass, and it failed. It didn't quite understand. So it's now uploading that to Astrometry. So it's basically, we've stopped and we've asked a local. Can you let us know the way to Polaris, please? So we're waiting now. And this can take a couple of minutes. So the best thing to do is usually to if I pause the video and wait, let's see. Here is Polaris. This is a 10-second exposure of that star. It's now in the center of the view, and the telescope is now happy that it's pointing in the right direction. So what does this mean though? What we can do is then use this to load up Stellarium. Stellarium is already running, as is another piece of software. This software here shows us the direction the telescope is pointing, so it's pointing due north, and the telescope is already connected here, so this is the electronic handset, as it were, so we can control the telescope from here, but mostly that's controlled, say, by the computer. But what we're interested in is in Stellarium, our star map. So let's go back to Vega. So there's Vega. Current object and slew. So we can open this app and it shows you the telescope moving. And we should be able to see the indicator move across the screen. Here we go. As it heads towards Vega. Vega's a fairly bright star in the night sky. It's useful for referencing, for focusing, and also just for hopping, star hopping. So if you're outside, going, okay, there's Vega, there's another star, etc. Okay, so according to this, we're in the right spot, and if we do a 5-second exposure, just to see if we're in the right place, should be a nice star in front of us. If the camera doesn't crash again. The camera keeps on crashing. Okay, that's gonna go horribly wrong. Okay, turn it off. Turn it, yes. Turn it back on again. Not entirely sure why this keeps happening. I'm gonna have to look into this. Back to imaging. So that's our old picture of Polaris. So we take a 5-second photograph now of Vega. Here we go. So this is Vega. Another, as I say, it's a very bright star. So what we wanted to do was to look at the Ring Nebula. The Ring Nebula is a planetary nebula. It's not actually a planet. It was just that older telescopes back in the old days, they were round shaped, so they thought they looked like planets. But what they are is stars that have died, and the outer edge, so as stars, some stars, as they age, they expand, and then after a period of time, they've used up all their fuel, and the outer edge just literally just puffs away, leaving behind the central white dwarf core in the center. So what we can do now is we will select the Ring Nebula M57, and then we can slew to it. So in the last video we said about the M's numbers are Charles Messier's catalogue. So here we go, it's now settled. And let's go to Nina. And we can take a 20-second image. The reason why we take longer exposures of nebulas and galaxies and things like that is they're quite dim compared to the stars, and we need to let all of the photons from those objects come in and be gathered by the camera, and we end up with a, hopefully, fingers crossed, this. This is the Ring Nebula. So the Ring Nebula, as you can see, has these coloured edges, different colours, and so over here is an image taken by NASA. If the browser will happily play. So here we go, taken with a multiple billion-dollar telescope compared to our one, but as you can see the colours, you can see the redness, you can see the bluey green in the middle, and you can see the yellow on the edges here. And each one of those colours are different elements within inside the Ring Nebula that are glowing. So for example, the deep blue in the centre represents helium, the light blue of the inner ring is the glow of hydrogen and oxygen, and the reddish colour of the outer ring is nitrogen and sulphur. Proving I can read from the internet. So we can just zoom, because we're at 39%, we can actually zoom in a bit. Like so. And there we go. There is the Ring Nebula. That star aged and died, and the outer edge blew away. Now, the distance to the Ring Nebula is 2,567 roughly light years away. So light is the fastest thing in the universe, and it has been travelling. This image that you see here, the light that you're seeing here, has been travelling for 2,567 years. So if we open up our calculator and we put 2021 minus 2567 gives us minus 546. So the light that you're seeing here right now, you're seeing from the image that we just took, left there in the year 546 BC. It's that far away, which is pretty amazing when you think about it. And as you can see, it's quite fuzzy, and the actual image itself and the outer area is a bit noisy, as we call it. This is simply because it's just one image, and if you're going to take deep sky images, you normally take multiple of them and calibration files that eventually you end up with a big stack of images that you then process and end up with quite a nice picture. So that was a quick look at the Ring Nebula and a couple of stars. This is just showing you all of the things that we looked at in the first video, putting them into practice in real life in the field. So the next time, for the next video, hopefully we get to look at either a couple of planets or even the moon or some other deep sky objects. But for now, if you like the video, please like it. If you want to see more, please subscribe or consider subscribing. Hit the notification bell, and that will then tell you if there's any new videos or if any live ones are happening, and if you would like to share them so that other people can see it, that would be great. So yeah, this is only the second one. Things will hopefully improve with each one as we go along. So yeah, that's that. Okay, right. Thanks for watching, and see you at the next one. Bye for now.